Okay, what we're gonna go through today is, I would say, a little different than what you normally see in the HVAC field, because it's actually part manufacturing. So we actually manufacture a lot of the stuff out on the field, and what we do is retrofit a machine. We're gonna skip a couple of parts today. We're going to jump right ahead, and you're going to miss out on the demo part, but this is what some of it looks like, prefabrication portion of it. This is where the contacts go for the compressors and some of the pneumatics. And over here we have a DDC panel, which is digital direct controlling, and here's your drive. Now I'm going to take you back, and we'll start at that end of the machine, and we'll go through what we've done to modify some of the things on the machine. So over here, what we have is we've put in some transducers so we could monitor the pressures of the system without having to gauge up. So we have our high and our low transducers on each circuit. This particular machine has 5 circuits. As you can see, we put them in, and then we start running our wire all the way back so we can communicate with the main controller, which is on that DDC panel that you saw before. And so we have to run the conduit and then the wiring. Then we have to get all our sensors together so it could sense outside air, mixed air, discharge air, just supply air, return, and then all of that, all of those wires come back to here, which is really the central monitoring station and switching of this whole system. So once we have all those wires here, we start to land, which is what we've been doing the last couple of days, and we're able to see when we actually start up and commission, we're actually see our pressures and temperatures. And in this controller right here, which is the FX15 made by Johnson, which supersedes the DX9100, we're going to put in the program, and based on that program, she's going to function and do different sequencing and stuff like that. Those of you that are familiar with the HVAC field, will obviously you know that something has to control the system. So this is what's going to do the controlling. This is all expansion modules associated with it. Transducer is how we're going to let the controller know what the static pressure in the duct is. In turn, it's going to drive the drive. And so in this system here, we have, like I said before, 5 circuits. And on this controller, we're going to be able to monitor superheats. We're going to be able to monitor high pressure, low pressure, condenser water in, condenser water out. Free cooling we can do with this. So, because we have the capability of taking the towers and speeding those fans up and getting on a cool day out, we could actually get 55-degree water, and it's good enough for us to cool this building down. We have our HOAs, handoff auto switches, on some things that we want to be able to switch on command. If someone comes up here, if one of the engineers comes up here and he wants to just switch something on, like outside air, bring it on, and things like that. And so, like I said when I started talking to you guys, that this is different in the sense that we actually put all of this together on site, piece by piece. We had to build this rack right here to hold up the panel, and so there's different facets that are going into this project. It's not just BMS or controls. It's more than that. We have to get into the refrigeration end of it. take out some things, put in some things. And in that sense, we have our pneumatics, our EP switches for, we can't totally get rid of all the pneumatics, so we incorporate digital direct controlling with pneumatics, and that's why we use the EP switches. And in that sense, it's different than what you normally see on just a control job. The task is a lot bigger, but we'll come back with another clip and show you the end result and see what you think then. All right? Thank you.